Hey, this is Mr. Charnetsky, and this is our points of concurrency on GeoGebra. So what we're going to do is we're going to go to GeoGebra and we're going to start our calculator. We're going to make sure we're in geometry, and we'll go ahead and open up our rest of our tools. And the first thing we're going to do is we're going to put 3 points down to make a triangle. We'll go ahead and connect those with segments. Okay. The first point of concurrency that we're going to do is called the circumcenter. And the circumcenter is made from perpendicular bisectors. So we could do it the old, like, construction method, two circles overlapping. But we have a tool in GeoGebra that allows us to just have it do the perpendicular bisector for us. So we're going to go ahead and click on perpendicular bisector. Then we'll click on one of our sides here, and we see it goes through the middle of our two sides and is perpendicular. Okay. And we'll go ahead and do that for all three sides. And you'll see that all three perpendicular bisectors intersect in the middle at a point that we call the point of concurrency. And this is a special point. This point actually is a point in which if we go to a circle and click on that point, and then click on one of our vertices, this point puts a circle around your triangle. And if I click on move here, what I can do is I can change the shape of my triangle, and no matter what, that circle stays around it. Okay, the circumcenter moves around, and sometimes it's inside our triangle and sometimes it's out. And basically in C, once we get to where it's a right triangle, that's where it's like right on one of our lines, and beyond that obtuse triangle, the circumcenter moves outside of our circle. Okay. So I'm going to do a couple things here. I want to save this point. Let's make it green first of all, and then I'm going to change the settings here. I'm going to call it the actual circumcenter. Okay. Now we're going to do some other constructions here. So I want to hide all this stuff except for my triangle. I don't want to delete it. So we're going to go to our algebra, and we're just going to delete, or no, sorry, not delete. We're going to toggle off our perpendicular bisectors. For the time being, we'll turn off our circumcenter and that circle. So just going back to our original triangle here. Okay. All right. The next one that we're going to do is called the incenter, and this is made from angle bisectors. Okay. So angle bisectors is right here under construct, and the way that we're going to do this is we're going to select 3 points, and the middle point will be the angle that we want. So if I want angle A, I'm going to do C, then A, then B. Then if I want B, I'm going to go A, then B, then C. In C, I'll do B, C, A. And once again, these are splitting our angles, and we get a point of concurrency right here in the middle. And we call it the incenter because it's going to place a circle inside of our triangle. Okay. Now this one's a little bit trickier. We need one more line to help us do this. One more point actually. So we're going to go to perpendicular line. So I'm going to click on perpendicular line. I'm going to click on my center point here, and then one of my sides. So probably this side right here. And I'm going to place a point right where they intersect. right there. Okay, so now I can place a circle right inside our triangle. Okay. Now the in-center, we can't get it to go outside of our triangle because, well, that wouldn't make sense. Our circle wouldn't be able to be inside our triangle if our point was outside our triangle. All right, so let's go ahead and change the color of this one. This one, let's make it red. And we'll call this the in-center. Okay. And we'll go ahead and we're going to hide all this again. So we'll hide all our angle bisectors and our in-center and our perpendicular line. Everything back to just our original triangle again. All right. This next one is called the centroid. And the centroid is going to connect lines from the vertices to the midpoints of our other side. So we're going to go to midpoint, and we're going to click on all three sides here. And then we're going to take our lines, we're going to go from a vertex to the midpoint across from it. Vertex to midpoint across. Vertex to midpoint across. Put a point in the middle. That is our centroid. And our centroid is the center of mass of this triangle. You can balance the triangle right on this central point. So let's give that a name. So we'll go ahead and color it purple. And we'll call it the centroid. Okay. 3 points down, one more to go. So we're going to turn off all of our points and our lines. We'll hide our centroid. All right. This last one is known as the orthocenter. It's the easiest one to do. It is made up of altitudes. So they are perpendicular lines. So basically, if we click on a perpendicular line, we go from a vertex to the other side. That's one altitude, basically measuring the height of our triangle. The same thing from this vertex over to this side, and this vertex to that opposite side. And we'll put a point there in the middle. And we'll go ahead and call it, let's color it orange. And we'll call it the orthocenter. Now, besides being interesting that it's another point of concurrency, there isn't really much that the orthocenter does. Just an interesting point on our triangle. Okay. Now the last thing we're going to do, we'll go over here to our algebra. We'll go ahead and turn those three lines off. We'll keep our orthocenter. Let's switch back on our other points. We'll turn on our in-center, our circumcenter, and our centroid. Tools here. And if we look at this, three of these Nice. 3 of these points lie on a line, and 1 does not. It's close, but not quite. And it's these 3, the centroid, the circumcenter, the circumcenter, the centroid, and orthocenter. Those are all on the same line. We actually call it the Euler line. And the incenter will not be on that line, except for one special case, and that is if I make an isosceles triangle. Just about there, yeah. If I make an isosceles triangle, then all 4 points will be on that perpendicular bisector that splits our isosceles triangle in half. And if I were to make an equilateral triangle, all 4 points actually coexist. In the same point in the middle of our equilateral triangle. All right.